Hi all, so we have discussed the first derivative test. So now we come to theorem number 2, which is second derivative test. Suppose that f is twice differentiable at the point x equal to c. So number 1, if f prime c is equal to 0 and f double prime c is greater than 0, then f has a local minimum at c. Number 2, if f prime c is equal to 0 and f double prime c is less than 0, which means that we have the negative value of f double prime, so f has a local maximum at c. Okay, number 3, if f prime c is equal to 0 and f double prime c is equal to 0 also, then the test is inclusive. Okay, that is, f may have a local maximum, local minimum, or neither at c. Let's look at example 12. Classify the local extrema of the function below by using second derivative test. We have the function fx equal to 3x to the power of 5 minus 5x cubed. So step 1 is to differentiate the function of fx. So differentiate fx, you will get f prime x equal to 15x to the power of 4 minus 15x squared. Second step is to determine the critical point. So how to determine the critical point? So what we need to do is to set f prime x equal to 0, which is we have 15x to the power of 4 minus 15x squared equal to 0. And what we need to do is to find the values of x. So what we can do now is factorize 15x squared, okay? And then we multiply with x squared minus 1 equal to 0. And from this, we will get x equal to 0 or x equal to plus minus 1. So how we're going to have the x equal to plus and minus 1? So we have x squared minus 1 equal to 0. So x squared is equal to 1, and therefore you will have x equal to plus minus 1. So we have obtain the critical point, which is the values of x. So now we need to find the values of y or the value of fx. So when x equal to 0, f0 equal to 0. When x equal to negative 1, okay, f negative 1 or y is equal to 2. And when x equal to 1, so y is equal to negative 2. So this is actually you get from the function given in the question. Okay, so from this we can have 3 critical points now, which are 0 0, negative 1 2, and 1 negative 2. Okay, so all these 3 critical points we will use for the next step. Okay, so step 3, we differentiate f prime, okay, to get f double prime. So f double prime, we will get 60x cubed minus 30x. And the last or the final step is to classify the critical points. So we have just now 3 critical points. Okay, so the first point is at x equal to 0. So we just substitute x equal to 0 into the second derivative. Okay, so f double prime, you will get 0. So based on the theorem 2, so when f double prime is equal to 0, so it's neither maximum nor minimum. Next, we move to second point, which is at x equal to negative 1. So when x equal to negative 1, so f double prime is equal to negative 30, which is negative 30 is less than 0. Thus, negative 1, 2 is a local maximum. And the last point is at x equal to 1. So we have f double prime 1 is equal to 30, which is greater than 0. And therefore, 1 -2 is a local minimum. Next, we proceed to inflection point. If you look back at example 12, you will see that at the critical point of x equal to 0, the point 0, 0 is neither a maximum nor a minimum. So actually this point is called an inflection point. So this is the characteristic of an inflection point. Here, number 1, when we were doing the first derivative test, we will notice that when a critical point is an inflection point, the signs of the slope of the function before and after the critical point do not change. And from example 12, the value of the second derivative test of the function equals to 0. So, therefore, one way to determine if a critical point is an inflection point is by checking the sign of both f prime and f double prime. So it is inflection point if the signs of f prime does not change before and after the critical point. And second, when the value of f double prime is equal to 0 at the critical point. Okay, so this is exercises, okay, 2 questions. So you can try to solve these 2 questions. Alright, so see you on the next class. Thank you.